Hi everyone, this is the audio file that goes along with the more detailed explanation of the individual sampling methods. It is really a very key component of the methodology of a study. I always tell students in the class when you're reading an article or hearing on the news or some type of media blitz the results of a study, and they'll say, studies have confirmed or research has shown. Ask yourself, where did they get this sample? Because in many cases, the sample is biased and it led to results that match that sample, but it doesn't necessarily mean that those same results would be found in a different sample or in the overall population, that they're giving you the belief system that it should matter that way. It doesn't always. So make sure that you're a critical reader. Look for biases that may affect the findings. Where did they get the people? What were their inclusion criteria? Should they have excluded certain people that they did not? And how did that influence the study? And also size. I didn't mention in the previous presentation about the Dewey versus Truman. It's always pointed out about size and representation. In that study, they analyzed tens of thousands of people related to who they were going to vote for in the general election. And they were so convinced that Dewey would win the election based on their polling results that they published the newspapers in advance. And as we all know, Truman won the election. And people were, how could this have happened? They had tens of thousands of people in the poll. Well, the problem was, where did they get the people? They took the people that they interviewed as to who they were going to vote for from phone books. And at that time, the only people who had published private line phone numbers were very well-to-do people. So their sample was very biased towards people who were wealthy or, on the upper income levels. And so when the general population vote was open to everybody, the voting was very different. The results of the voting were very different. So you always have to ask yourself about sample. So the type of sampling methods, again, it depends on what your purpose of your study is, depending on what the best sampling method is going to be to answer that research question, to serve your purpose of your study. Probability sampling is always touted as the best type of sampling to use because it does reduce systematic bias. The basis of probability sampling is that every subject in the population, all of the population, have some chance, greater than zero, of being selected for the sample. Some people will say, well, you all have an equal chance, but as long as every person in the population has some chance of being in the sample, then you're talking about probability sampling. Non-probability sampling is more fraught with bias. However, it is one of the most commonly used approaches because in research, we do not have the capability or even the possibility of using the all list, the all population list. There is no such list of all people who have hypertension. There is no such list as all people with HIV. There are lists that may exist at individual clinics or at different, provider sites, but there's no such master list of everybody. So we have to be cautious when we say, well, we want to use probability sampling. So let's talk about each of the individual types. Probability sampling, your book goes into the four major ones: simple random, stratified random, cluster random, and systematic random. We'll talk about each of those. And then the non-probability types: convenience, quota, network or snowball sampling, and then purposive or theoretical. Your book differentiates to a greater degree purposive and theoretical. I will not, and I'll explain that when we get to that slide. Simple random sampling, the key points: you should see the words master list. If there was a master list of all of the subjects in the population, the sampling frame, and then the subjects were selected randomly from that overall master list. If it's a small enough list, you could have just put names in a hat and draw the names out of a hat. You could use a random numbers table. You can use a computer program. You can go online, like if you put a list of people's names in an Excel file, then you can ask for a randomly generated list of, let's say you entered in 120 names, you could ask for a randomly selected list of 20 names. And it does reduce bias when you use simple random sampling. An example would be, using a computer program, 100 critical care nurses were randomly selected from the master AACN membership list of critical care nurses. Now, our population there is the nurses who belong to AACN's organization. It does not necessarily mean all critical care nurses, because there would be a group of critical care nurses who might not belong to AACN, right? Maybe they haven't joined the membership, or that they don't have an interest in joining the membership, and their agency that they work at does not require that to work in an ICU. So you could have something that might throw that off. But if you have a master list and you say that your population is nurses who are enrolled as members in the AACN Critical Care Nursing Organization, that would be your master list. You would randomly select, using a computer program, those 100 critical care nurses to be in your sample. Stratified random sampling. You know that there are variables that are critical to being representative in your population. For example, gender, ethnicity, marital status, educational levels. Oftentimes we see them as strata listed in samples. If we believe that it's going to affect our outcome in some way, then we might want to randomly select within those strata. The thing with stratified random sampling is that we randomly select from the master list within those strata. Okay? It is associated with the lowest sampling error. You can recruit proportionally or disproportionately. Proportionately means that if, like in gender for nursing, if we have 85% female and 15% male, our final list would look like that. If we have disproportionate stratified sampling, we would randomly select, but we would maybe not worry about, maybe we think, only having 15 men compared to 85 women, is really 15 enough to get a voice of the male perspective. So we might say we don't want to do proportionate, so we might balance that out a little bit and maybe make it 60-40 or even 50-50. So here's an example of how you determine strata. They divided up the hospital based on type, public, university, or private hospitals. There were 17 of them. The number of nurses that worked at each of those strata, 950 nurses worked in public hospitals, 265 worked in university, 300 worked in private. Then they divide the number of nurses over the total number of nurses, and they get the representative strata proportion. Then they multiply. They wanted a total of 350 nurses in the sample. So using that strata weight, they multiplied times the desired final sample of 350 in column 5. That's how many nurses they attempted to recruit from within each strata. You'll see that 17 nurses in the first strata did not enroll in this study, and only 1 did not enroll from strata 2. So that might be something that they would have to explain, but this is an example of stratified proportionate sampling. Cluster random sampling means that clusters or groups exist at various locations. There's not necessarily one, I apologize for that spelling error there. There's not necessarily one site that has the master list, but there are multiple sites that exist that have master lists. So we might have multiple sites of patients who have been enrolled in an experimental type of drug, and we might have some people out in California, some people in Illinois, some people in Florida, some people in New York. And the researcher doesn't necessarily want to go to each of those areas, so what they'll do is they will randomly select clusters, and then from within those sites they'll get the master list and they'll randomly select. It's a way for them to, if you have wide geographical areas that you need to cover, that you could use this. Many times it's used with public health when they're trying to use like census tracts, they're trying to get representative areas across the city. They would use cluster random sampling. And the example is here, they had 169 total nursing programs, but only in 6 regions. So they used 30 they selected the clusters, then they used 30 programs randomly selected from those regions, and then they used random sampling from within each of those programs to get their final sample. Systematic random sampling, you use it when there's an ordered list, and the researcher determines what they call the kth selection. It's based on the final sample. You have to be careful if there's any patterning in the list that might introduce a bias. Let's say The researcher was asked to give 10 names, a charge nurse was asked to give 10 names of nurses on her unit that might want to participate in research. And every nursing unit on the area put 9 staff nurses and then put the charge nurse's name as the 10th. Well, suppose the researcher said, I'm going to use every 10th nurse's name. They would get, inadvertently, they would get all nurse managers, and it would not be representative of the staff. So, example, researcher had a list of 1,200 patients. They took charge in a discharge support program. The researchers now wanted 100 of these patients in their new study. So they with a random start on this ordered list, they select every 12th name. 1,200 in the original, they want 100, so it would be every 12th on the list to recruit for the study. Convenience sampling is also called accidental sampling. Right place, right time, you have the people available to you, it's quick, it's easy, inexpensive. You have to be careful about it in experimental studies, very commonly used, but random assignment should help to control for some bias, but not all. It does have to be cited as a limitation of a study. You also can minimize bias by having very strong inclusion and exclusion criteria. A convenience sample of 60 heart failure patients in the clinic was obtained. Researchers enrolled the first 100 persons approached in the ER waiting room who met the eligibility criteria and agreed to be in the study. That's also called consecutive sampling. It's a form of convenience sampling. Quota sampling is very similar to stratified random sampling. It relies on knowledge of these certain characteristics or sets of characteristics that exist in the population, and in order to be more representative, you want to base your sampling on these strata. The difference is in quota sampling, once you identify the strata, there's nothing random after that point. You then use convenience sampling. Once you have your strata, you get the individuals from within those strata using convenience sampling. It's better than convenience sampling because it does help with representation, but it's still not random sampling. Researchers recruited 25 volunteers between freshmen, sophomores, juniors, and seniors by attending course meetings taken by each class. So they would go to a class of all freshmen. They would get 25 freshmen. They would go to classes that only had sophomores. They would recruit 25 sophomores. A class of juniors, a class of seniors, get 25 people from within each of those. Convenience sampling once we identify the strata. Network sampling is used when we think that we don't have access to the subjects that we're interested in. They're not the type of people who make ready contact with healthcare professionals, first off, and certainly not researchers. There's a distrust inherent in that process. So we count on people that we early on recruit, and then we ask them to make referrals to us. Sometimes it's called referral sampling as well. And here's an example here of how we can build from 3 people to getting 12. The original participants, and then each of them gets us 3 people. Purposive or theoretical sampling. Purposive sampling is also called judgmental sampling. It's used almost always in qualitative studies. The researcher deliberately tries to recruit people into the study who they think will give them the best data. So they get exemplar cases, the best worst scenarios, typical, atypical cases, depending on the kind of question that they're asking. Purposive sampling is called theoretical sampling. This is the difference. Your book goes into a lot of detail, but really, basically, it's called theoretical sampling if it's used in a grounded theory study, where the purpose is that you're trying to find data to support developing your grounded theory. And an example is, researchers sought to describe the experiences of parents caring for a child with ADHD. So they would go out of their way to find parents who had a child who said they were either controlled or not controlled. They want to show both sides. The child was an only child, or they had a child that had siblings. Show that effect of the siblings. Diagnosed newly or a more, longer period of time. Because they want to show that there were differences in this, and they want to present the bigger picture. And so, again, it's to meet the purpose of their study, but they find very deliberate cases. Thank you.